Okay, so what? We're back. Okay, so one thing I want to point out was this whole. Looks like we're kind of doing the whole camera jumpy thing again. Let me know if there are any streaming issues, and I can turn the camera off. All right, let's see. What was I going to talk about here? The different types of exceptions, right? Okay, so I've done a little change. I've done a little change to this this program during the break, and this is what I want to show you that we have now. Okay, so we're going to catch the runtime exception down here. Okay, we're going to catch, if the runtime exception is not caught, we're going to catch the IO exception. If that's not caught, we're going to catch exception, right? And if that's not caught, then we do not. Okay, so let's see about these different types. Okay, so we're going to throw a runtime exception. Okay. So now we're going to call with a valid value. Actually, we can just step over that because we just know what's going to happen. Method 4, 5, method 4 after exception, method 3 after exception, method 2 after exception, method 1. Done. Okay. We called with a valid value, no exception was encountered. Okay, invalid value. We try to call method 2. We try to call method 3. We try to call method 4. Right, but an exception is encountered. A runtime exception is encountered. So we are not going to display this. We're going to skip over that. We're going to go straight to the catch block. That's the correct type. So we say we caught the runtime exception and we continue on with what we had before. All right, so now because that exception was caught, we don't have to try to catch another one. Right, there's no exception anymore. We caught it, we dealt with it, it's done. Everybody's happy. We just keep trucking like we did before, keep on moving. All right. Okay, so what if the exception type that's thrown isn't the same as this? So let's give it the IO exception. Okay, we're going to skip over the valid value. We're going to go into here, right? Okay, so now we throw an IO exception. We can't catch that because it's not the same type, right? So we're going to go back up to its calling program where it is the same type. So now IO exception was caught. All right. So now because it was caught and processed, we don't do anything more. Okay. And then finally, if we just throw an exception. And debug, okay, skip over the valid value. And step in. We keep going down until we get an exception, which doesn't get caught. So it was thrown here, wasn't caught in method 4, wasn't caught in method 3. It is going to get caught in method 2. Okay. Now, what if, let me go back, and I make this a runtime exception. And I said, you know what? I never caught that. I never caught the runtime exception up here. So I want to catch that runtime exception here. Okay. Okay. We should be happy here. Okay. Skip over the valid value like we've been doing. Okay, so we throw the runtime exception here. Catch it. Okay, so not the right type. So okay, so we're done, right? Okay. Now, when we go back to method 2, back to method 1, because we're in method 2 now, right? We just finished method 2. We're going to come back to here, and we threw a runtime exception, so it should come here, right? But why isn't it catching the runtime exception? Why isn't it catching the runtime exception? Yeah, it already was caught. It was caught down here, right? Like, I don't know if you guys watch American football or baseball or basketball. Okay, I know some of you gotta watch NBA, right? Everybody asks me if I watch NBA. I don't watch NBA. I don't really like basketball, right? But if a guy catches the ball, no one else can catch the ball, right? Once the exception is caught, it's done. There is no more exception. There is a way that it can happen again, but we'll talk about that tomorrow. Okay, but it's already caught. It's gone. There's no exception anymore, right? There's no error that's outstanding. It's already been caught and dealt with. So it doesn't exist anymore. It can't be caught again. Okay. All right. So let's move on back to over here. Okay. Now, there are some exceptions that are checked, right? So if the compiler knows that there's an exception that exists that could exist within a method, that could be thrown within a method, right? Like IO exception, for example, right? Then it makes you declare it. So it makes you either have to put it in a try block, or you have to say throws exception. It could be IO exception, it could be file not found exception. This comes back to what we talked about last semester when we talked about text and reading from a file, specifically reading from a file. Right? If you use the file class to read from a file, the compiler knows there could be an exception if the file is not found. Right? Because it knows that, it says you have to say how you're going to deal with it. You are either going to try and catch the exception, or you are going to throw it up to the calling program. But you have to tell the compiler, I know what I'm doing with this. Okay. All right. I said we were going to do this tomorrow. I didn't realize it was this soon. I thought it was a few slides later. Right. So there is a way that if after processing through an exception, we can throw it again. Okay. We can say, I know that the exception occurred. I know I did some stuff with it, but I want to rethrow it. I caught it. Now I want to throw it again. All right, so let's see what happens with this. All right, here we caught the runtime exception. So now I threw the runtime exception. It throws a runtime exception. It catches the runtime exception. And now it's going to throw the exception again after it does some stuff. Okay, so let's see what happens with this one. Okay, so we go down, we go down, we go down. Okay. So now we throw the runtime exception, which means we're going to skip this line, right? The runtime exception is caught. Okay. Now, where do you think this is going to go? What's the next thing that will happen? Will it display this? Will it display this? Or this? Okay. Just throwing runtime exception. What about here? So we know it's going to either continue on here and do this, or it's going to come back here and do something, or it's going to come back here and do something, or it's going to come back here and do something, or it's going to come back here and do something. Think about, what do you think it'll do? Is it going to come back up here? It's tough, huh? All right, let's take a look. Okay, now hopefully you've thought it through and figured out what you think is going to happen. So after it throws this exception, it goes to here. Okay, now you might think, wait a second, why didn't it come up to here? That's exception. This is runtime exception. It's a runtime exception. It's not an exception. All right. What could it be? Why could it do this? Why does it do the exception? Why did it do this one? The answer is right here. A runtime exception is a type of exception. Okay. So when I say catch exception, I'm saying catch exception and any of its children. Okay. So when I say catch exception, I'm saying catch exception or any of its children as well. Okay. So then we keep going. Okay. But we don't catch it here too because it wasn't rethrown. Now it was caught and dealt with. We can rethrow it here. We can rethrow it there, and now it'll be caught here as well. Runtime exception caught, we throw it again. We caught the exception, we throw it again. We catch that runtime exception. We caught the runtime exception. Method 1 is the only thing that gets executed after calling with invalid value. Okay. This is important to understand that why would we maybe want to throw an exception again after catching it? If we've processed it, why would we want to throw it again? What do you think? What might be a reason that we would want to do something? Okay, an error occurs. An error happens. We catch it, we process it, and then we throw it again? Like, what's the point of processing it if we're just gonna throw it again? What might be something we might want to do where we would want to rethrow an error or throw an error again? What do you think? What do you guys think? What might be a reason to rethrow an error? No one? It's too late in the day. Oh, John, I'm so tired. I would say you want to go to sleep, but that's not true. It's too early at night for you to go to sleep right now, right? Many of you are like, I just want to go hang out with my friends, right? Consider this. What if we have some type of error that should end the program? Okay, it should not. The program should not continue. It's that type of system level ending error. Okay? But we want to log that the error occurred. So what we might do is inside of a catch block is we might write to a log file saying, hey, this is an error that occurred. But then we want to throw that error again so that it ends the program. Okay, that's one possibility. We might want to display some information to the screen to say, hey, this thing occurred, right? And this is why I'm ending the program. And then throw the exception up. Okay, those are all both possible ways that it might be useful there. Okay, let's show one more thing where we catch the runtime exception a few times. So here we throw it, we catch it inside the method 4. We rethrow it. It doesn't get caught in method 3 because it's not the same type of exception or a parent class. Remember, exception is a parent class to runtime exception, right? So it gets caught here and then it gets rethrown. It gets caught here because that's the same type. So we caught it, we rethrow it. Now when we throw it, nothing up here is to catch it. Nothing up here is going to catch it. So it ends the program. Okay. All right. Let's move. Oh, what slide were we on? Is that one? Oh, the rethrow. Right. Okay. There is one more clause that we're going to talk about. Okay. And since this is a lot of new information that you guys have been given, we're going to talk about this. We'll show an example. And then we will call it a day because this is going to be a lot of new information for you guys. And then we'll pick up tomorrow. All right. So here's how the program flow works. Let's see. Let me give some different possible inside of statements. There's some different possible things that could happen. There's no exception that occurs. Okay. and we'll call this 1, 2, 3. Okay, one set of statements 1, set of statements 2, set of statements 3. Okay, no exception occurs. An exception of the type that is caught occurs, or a child of this type, as we saw. So if this is exception, the exception class here, it catches all exceptions, regardless of the type, right? So if this is the type or a parent type of the exception that's thrown, then we'll do this. Okay, the exception, or an exception that's not the type, not the type of exception. Okay, so no exception occurs. An exception that is of the type the exception occurs. An exception that's not the type of exception occurs. Okay, hope that's clear. All right. So no exception occurs. We execute all of the statements in the try block. No exception occurred, so there's nothing to catch, right? So then 2 doesn't happen. So then 3 occurs. Okay. An exception of type the exception occurs within the statements. We'll call it 1A. Okay, here's why. Some of those statements are probably going to execute up until the exception happens. Any statements that are written after the exception event do not get executed. Okay, so some of the statements do get executed, but not all of them. Okay, all right, so some of these, but not all. We go into the catch block because it's of the type, right? So then 2 is executed, right? And then finally executes. So then 3. Okay. Finally, our examples here. An exception of a type other than the exception occurs. Okay. So again, we execute up until whatever exception is thrown happens. We don't catch the exception because it's a different type. We tried to catch runtime exception, but an IO exception occurred, for example. So we don't execute number 2. We still execute the finally block. Okay. Notice 3 always occurs, right? 3 always executes. The finally block executes regardless of if an exception occurred or not. So if we trace through the program to see how an example might happen, no exceptions occur. We execute final statements, we go to the next statement, we keep on going. Everybody's happy. Okay. An exception of type exception 1 is thrown. So statement 2 executes, statement 2 generates an exception of type 1. We catch it, we handle it, we execute the finally statements, we move on to the next statement. An exception of type 2 is thrown in statement 2. We execute statement 1, we get the exception. It's a different type than exception 1. It's of type exception 2. So we do the catch. Now, we handle it, but notice that we also rethrow it. Okay. So there's an exception hanging out there. Right? What happens? Do we go to finally? Do we go to next statement? Hey, No to what? No to finally? Do we go? Yeah, so no to next. Okay, so we do finally and then that's it, right? We execute the finally block. Because there was a throw exception, we're done. We don't execute the next statement, right? So let's look at a couple of examples and then we will call that a day. All right. So we'll put one of these in every block, yeah. But we'll do this my method 3. My method 2. My method 1. All right, okay. Let's just leave this as is. Yeah, that's fine. Okay. Let's first actually, let's do this. Let's throw. All right. I did not mean to click run. I meant to click because it needs to debug. All right. So we're going to step in. Okay. So we call down to where we get to an exception. An exception is thrown, so we don't go in my method 4. We catch the exception. We process it. All right. My method 4 finally. My method 4 after exception. There's no exception going on now, right? So we're done. We just keep going back up the chain with no more catching that needs to be done. All right. Okay. Let's make this a different type. Okay. Okay. So now we're going to throw an IO exception, but it's not a runtime exception, so we won't catch it. But we still execute the finally. Okay. We still execute the finally. Then we come up here. Now we catch the IO exception. All right. And we execute the finally. All right. No exception to be caught anymore. That's right. So now we execute all the code there. All right. Let's do one more. So we caught the IO exception. I'm going to rethrow. Let's do one more and then we'll call it a day. Okay. An exception is thrown. An IO exception, not caught by the calling program, by this program. All right, but we still execute the finally block. It is caught by my method 3. All right. IO exception caught. We are going to rethrow the exception so it's still out there, but we still execute the finally block. But we don't execute this because there is an exception that now has to be dealt with. There's still an IO exception that's out there. Okay. This catches the exception because exception is a parent, is the superclass to the IO exception class. So we catch it, caught that exception. It also rethrows it. Right? So the exception that's still out there is an IO exception. But again, we still execute the finally block. Right? Here, we had a catch block, but it was the wrong exception type. Right? So we didn't execute any of this. This is where the exception occurred. So we didn't execute this line at all. We jumped straight to the finally block. All right. And then once that's done, the exception, IO exception, now no longer exists, right? No longer was able to be caught by anything. So it just got shuffled up to the main program. Okay. I do want to make one statement before we close for the day. One thing I've realized I meant to say earlier. The null pointer exception. I don't remember how that occurred. Let me look back at your messages after the class is over, or maybe I can do it if there's still some time. One of the things I want to say was throwing an exception by using the throw keyword is not the only way to create an exception. Okay. For example. Okay. Wait. Why is a variable declaration all low? Allows me to do that. Okay. Oh, that's weird. Okay. So this, notice I don't have a throw new exception at any point. But let's see what happens. Okay. A equals 0. N is less than 0. It is. All right. So what's going to happen here? It's going to generate a runtime exception. So this is a type of runtime exception. It's specifically an arithmetic exception. Okay, because I tried to divide by 0. Notice I didn't have to use throw new something, right? I only had to generate some type of exception through a normal means, okay, through another method, right? But it results in a similar outcome, okay? Saeed, let me go look back at your messages real quick. Null pointer. Oh, null pointer is if we try to. So let me show you an example of null. I know what you're talking about now. I got it. A null pointer exception would be something like this. Okay. Let's do this. This should work. It does tell me that. I'm not gonna force it to happen. allow me to do this maybe. Okay, yeah, it allowed me to do that. All right, so this should do it. Actually, now that I think about it, it actually won't give me that error. Yeah, okay. Because of the reason for why. Okay, this might work. Yep, there it is. Okay. So this is what I think you're asking about, is something like this. So notice that the compiler knows that MC points to is a variable that can hold an object of type myClass. MC1 is a variable that can hold an object of type myClass. MC1 get myInt, no compiler error, right? Because myClass has a method called getMyInt. Same thing with MC itself, right? It can hold a variable type myClass, so it has access to this method called getMyInt. But when I go to try to access it here, what happens? Well, the thing it points to is null. It's not existent. There is no getMyInt method for this object because it's nothing. It's null. Right? So that's where the null pointer exception comes into play. Right? Because it points to an empty object. It could point to a myClass object. But because it doesn't point to that, it therefore cannot access the getMyInt method. Okay. Now, I'll say this. The reason why when I did this initially and I tried to compile this, it gave me an error. Gave me a compiler error, not in runtime, but a compiler error, is that it's saying, hey, you created this variable, but I don't see anywhere in your code where you set it to anything. So then, what about this? Will it like this? Let's see. It likes it. All right. So the fact that I gave it an assignment of some kind, the compiler says, okay, that satisfies me. That you assigned it at some point to something, right? But this will get a runtime error, right? Or a null pointer exception, because this now points to null. It's nothing. It's not an object. So therefore, when I try to access the method for that, null doesn't have this method. Okay. All right. So that's why we need to make sure that when we go to use a method of an object, that it actually points to an object of that type. Okay. Good question. I hope that clarifies that. If that's still not clear, let me know, and maybe we can try to figure out what's not clear there. All right. Any other questions or comments? Anyone? Nope. Okay. Thank you guys for joining us. We will continue on with our discussion about exceptions tomorrow. Remember, the whole point of why we're going through this is sometimes we want to create errors. Like we want to create error conditions if the inputs are not okay. If we try to read from a file that doesn't exist, that should create an error. If we try to divide by 0, that should create an error. If we try to create an object that represents a circle with a negative radius, that should create an error, right? Errors in and of themselves are not bad. They're just showing places where conditions are not good for the program to continue running. Okay? All right, guys. Have a good afternoon, have a good evening, and I will see you tomorrow at 1:30.